Welcome to this video on voltage and current dividers. In this video, we will explore how circuit configuration helps with circuit design and some basic rules for analyzing circuit behavior. The voltage and current divider rules will be explored with an explanation of where they come from. Firstly, it is important to consider some motivation for learning these concepts. The voltage and current dividers are important as they allow the engineer to control how voltage and current is divided between components. This allows circuits to behave as desired. For example, say you wanted a dimmer switch. Changing the ratios of R1 and R2 will make the voltage out bigger or smaller, so the light gets brighter and dimmer. This is an application of a voltage divider. There are many more applications to consider, but first we need to understand these rules. The voltage divider makes use of a series circuit with two resistors, R1 and R2. Here, around the loop, as in the previous video, the sum of voltage is 0. Also, current is the same throughout the circuit. Hence, we can write V is equal to V1 plus V2, then use Ohm's law and some algebra to get this final form of the equation. Notice that V out is equal to V2, as if we had a voltmeter across it. The rule is that if we want V1, then R1 is on the numerator of the fraction, and if we want V2, then R2 is on the numerator as shown. The current divider makes use of a parallel circuit with two resistors, R1 and R2. Here, the total resistance is the inverse of a reciprocal sum. This can be proven in a later video. Once again, if we substitute in Ohm's law, then we can make use of algebraic manipulation to get into a more useful form. As in parallel circuits, the voltage is the same in each branch, so for the whole circuit, V is equal to I times R total. Using equivalent voltages, V equals V1, which also equals V2. So if we want current I1, we can substitute I1 times R1 into the expression and rearrange. The rule here is that the current in one of the branches is determined by the resistor in the other branch. It is useful to think of this as the current following the path of least resistance. So if R1 is much larger than R2, then I2 will be much larger than I1. We conclude with some final remarks. This video has covered why voltage and current dividers are important in circuit design. Understanding where the equations have come from has been covered as it is key to ensuring these rules. Subscribe for more, and don't forget to check out our other videos.